on, so we have this amazingly weird function here on the grid, on the following grid, sketch the graph. It says between 20 and 200. Okay, so that's only one x values between 20 and 200. Lots of people lost marks because they drew exactly what they saw. So first thing, I'm going to set up my axis so it looks like this. So I'm going to go from 0 to 220 on the x and 0 to 160 on the y. So 0 to 220 on the x, and I'm going to go up in multiples of 20, and 0 and 160. Oops, so Daisy did it again. And 160 in multiples of 20 on the y. Okay, I'm then going to input this function. So, oh, I've forgotten what it was. So 95 e to the negative 0.02x e, which is down here, to the power negative 0.02, and this is my variable, plus 40. I'm going to enter that, and then I'm going to graph it. Now, we're going to draw this on this grid because we know that this is 20, 40, 60, 180, and so on and so forth. Now, they only want us to go from 20 to 220. So this 20 value probably starts around here at 2, 4, 6, 8, 10, 12, about 120, maybe just under, between 100 and 120. Did this go up in 20s? Yeah, so 20. So just over 100. And then my 220 was here, 2, 4. And, oh gosh, that was bad. I'm doing it with a mouse. That was a bit silly. I'll just do it with a pencil. Okay, try and make it look like your screen. Oops, that's a bit rubbish. Anyway, you're going to do it a lot better than that when you do it. Okay, next question. Robin and Pat are planning wedding banquet. The cost per guest. This is something that lots of you missed. The cost per guest is modelled by this, where n is the number of guests. Calculate the total cost for 45 guests. So we're going to do 95 multiplied by e to the power negative 0.02 multiplied by 45 plus 40, and then we're going to multiply that by 45 because n stands for the number of people, and that's the cost per guest, and then you're going to multiply by 45. So we can chuck that in the calc. So 95 multiplied by e to the negative 0.02 multiplied by 45, close bracket, plus 40 equals, if you want to write that as a mid step, and then multiply by 45, gives 353,809. Okay, I've lost it. 35380. Next question. Okay. So we've got points P, Q, and K. The tangent to the curve FP is perpendicular to the tangent of Q. Right, so if we're talking about perpendicular tangents, if we're talking about tangents, we're going to be finding the derivative of this at some point. Okay, so let's find the derivative function. Okay, so we've got two things, one on top, one on the bottom, so there we go. Oh, that's the wrong one. We need to find the derivative of a quotient, so we're going to be using this rule. Okay, so in our case, u is ln 4x and v is x, so du dx is going to be 1 over 4x multiplied by 4, and dv dx is just 1. So let's put that in here. So f dash x is v, which is x, multiplied by du dx, which is 1 over x, subtract u, which is ln 4x, multiplied by dv dx, which is 1, over v squared. So that is x multiplied by 1 over x is obviously just 1, subtract ln 4x over x squared. Okay, so we know that the tangent of f at P is perpendicular to the tangent at Q. Okay, so at P we're going to find the gradient because we're going to stick the x value in now. So it's 1 subtract, oh that says ln, 4 lots of 0.25 over 0.25 squared, 1 subtract, so 4 lots of 0.5, so that's ln 1 over 0.25 squared. Let's subtract that in our calc. So alpha y equals 1 subtract ln 1 over 0.25 squared gives us 16. Okay, so that's the derivative of the tangent, and that's perpendicular to the tangent at Q. So the gradient of tangent at Q is negative 1 over 16. Okie dokie smoky. Okay, so we know that the gradient of the tangent at Q is negative 1 over 16. So what we need to do is find where is this gradient function equal to negative 1 over 16. So the easiest thing to do is to put in your function here. So we've got 1 minus ln 4x over x squared. Where is that equal to? Let's write negative. Oh, let's put it in. Alpha y equals. So negative 1 over 16. So where is it equal to negative 1 over 16? So where is our gradient function equal to negative 1 over 16? Graph it. Okay, make sure your view window is suitable. As long as you can see where the lines cross, you can just leave it like that. I don't have to zoom in. If you wanted to zoom in, you could. So then we're going to do second calc where they intersect. So we need to see where is, so my flasher is on the blue curve, this first curve. It jumps to the second curve, it guesses, and then tells me that the intersecting point is at 0.7007, so that's 0.701. Okay, and then we're going to stick that value 0.701 into the original function. So ln for alpha equals ln 4 multiplied by 0.701 over 0.701, which is 1.47 to 36 fig. Okay, done.